Let us find the prime factorization of 3825 using the factor tree method. We start with 3825. Dividing by 3, 3825 divided by 3 equals 1275. Dividing by 3 again, 1275 divided by 3 equals 425. Dividing by 5, 425 divided by 5 equals 85. Dividing by 5 again, 85 divided by 5 equals 17. 17 is itself a prime number, so we stop here. Collecting all the prime factors from the tree, 3825 equals 3 times 3, times 5 times 5, times 17. Writing this in index notation, 3825 equals 3 squared, times 5 squared, times 17. This is the unique prime factorization of 3825. The fundamental theorem of arithmetic states that every composite number has a unique prime factorization. Let us factorize 32760 using the division ladder method. We divide by 2 to get 16380. Then by 2 again to get 8190. Then 8190 by 2 gives 4095. 4095 by 5 gives 819. 819 by 3 gives 273. 273 by 3 gives 91. 91 by 7 gives 13. And 13 is a prime number. So 32,760 equals 2 cubed, times 3 squared, times 5, times 7, times 13. Every composite number has exactly one such factorization. This is unique. Now let us look at the factor tree for the number 60. 60 branches into 2 and 30. 30 branches into 2 and 15. 15 branches into 3 and 5. Therefore, 60 equals 2 squared, times 3, times 5. Let us practice building factor trees with 3 examples. Example 1. The number 140. 140 splits into 2 and 70. 70 splits into 2 and 35. 35 splits into the primes 5 and 7. Therefore, 140 equals 2 squared, times 5, times 7. Example 2. The number 5005. 5005 splits into 5 and 1001. 1001 splits into 7 and 143. 143 splits into the primes 11 and 13. Therefore, 5005 equals 5 times 7 times 11 times 13. Example 3. The number 7429. 7429 splits into 17 and 437. 437 splits into the primes 19 and 23. Therefore, 7429 equals 17 times 19 times 23. In every example, we reach unique prime factors, confirming the theorem. Exercise 1.1, Question 2. Find the LCM and HCF of 26 and 91, and verify the property LCM times HCF equals the product of the two numbers. Step 1. Prime factorizations. 26 equals 2 times 13. 91 equals 7 times 13. The common factor is 13, highlighted here. Step 2. Calculate HCF and LCM. HCF equals 13, the common factor. LCM equals 2 times 7 times 13, which is 182. Step 3. Verify the property. Left-hand side, LCM times HCF equals 182 times 13, which equals 2366. Right-hand side, the product of the two numbers, 26 times 91, also equals 2366. Left-hand side equals right-hand side. The property is verified. Exercise 1.1, Question 3. Find the HCF and LCM of 12, 15, and 21. The key technique is to align the prime factors vertically. 12 equals 2 squared times 3. 15 equals 3 times 5. 21 equals 3 times 7. Looking at the columns, the factor 3 appears in all three numbers. The factors 2, 5, and 7 do not appear in all three. Therefore, HCF of 12, 15, and 21 equals 3. For the LCM, we take the highest power of each prime factor that appears. LCM equals 2 squared, times 3, times 5, times 7. Calculating step by step, 4 times 3 is 12, times 5 is 60, times 7 is 420. LCM equals 420. Let us find the HCF and LCM of 510 and 92. Prime factorization of 510. 510 equals 2 times 3 times 5 times 17. Prime factorization of 92. 92 equals 2 squared times 23. Comparing both factorizations, the only common prime factor is 2. Therefore, HCF equals 2. For the LCM, we take the highest powers of all primes present. LCM equals 2 squared, times 3, times 5, times 17, times 23. Calculating, 4 times 3 is 12, times 5 is 60, times 17 is 1020, times 23 equals 23,460. Verification, HCF times LCM equals 2 times 23,460, which is 46,920. The product of the two numbers, 510 times 92, also equals 46,920. The property is verified. Let us find the HCF and LCM of 336 and 54. The two numbers are shown at the top. Prime factorization of 336. 336 equals 2 to the power 4, times 3, times 7. Prime factorization of 54. 54 equals 2 times 3 cubed. For HCF, we take the common primes with their lowest powers. The common primes are 2 and 3. HCF equals 2 to the power 1, times 3 to the power 1. That gives HCF equals 2 times 3, which is 6. For LCM, we take the highest powers of all primes. LCM equals 2 to the power 4, times 3 cubed, times 7. That is 16 times 27 times 7, which equals 3024. Verification, 6 times 3024 equals 18,144. And 336 times 54 also equals 18,144. Verified. Let us find the HCF and LCM of three prime numbers, 17, 23, and 29. Since each of these numbers is itself a prime, their only factors are 1 and themselves. 17 equals 17 times 1. 23 equals 23 times 1. 29 equals 29 times 1. For the HCF, there are no common prime factors shared among 17, 23, and 29. Therefore, the HCF is 1. For the LCM, since the three primes have no overlap, the LCM is simply their product. LCM equals 17 times 23 times 29. Calculating, 17 times 23 is 391, and 391 times 29 equals 11,339. This illustrates an important fact: for distinct prime numbers, HCF is always 1, and LCM is always their product.